So this is the homework video 448. We're on page 231, 1 through 6, 8 through 13. So number one, we're going to fill in the blank with either and or. So when we have an inequality written like this as an interval, x is greater than negative 8.2, less than or equal to 4.75. What does it actually mean? If you split them apart separately, so x is greater than, there's that. X is less than or equal to, there's that. Does this mean they both have to be true? That would be and. Or does it mean or, meaning only one of them needs to be true for the solution to be true? So it's important to know when it's written like this, when it's all connected, this means that x has to follow both of these at the same time, which is and. So x has to be greater than this, and it also has to be less than this at the same time, not one or the other, at the same time. So that is and. All right, 2 through 5. We are just matching these up with the graphs. So as we take a look at these graphs, this right here is everything between negative 2 and 5. This is everything less than negative 2, everything less than 5. And then this is both everything less than negative 2, but also greater than 5. Now, if you look at all these, they're very similar. They've pretty much just changed the ands and the ors and maybe flipped some less than or greater than signs. So when I look at this one, it says or, meaning they both don't have to be true. So x is less than negative 2 or x is greater than 5. It doesn't have to be both at the same time, which it couldn't be if you think about it. Less than negative 2, that's negative 3, negative 4, negative 5. Greater than 5, that's 6, 7, 8, 9. Could never be both. So this is and or. So this is everything right here. Less than negative 2 or greater than 5. So 2 is letter D. This one we just talked about, this is an and statement. So x is greater than negative 2, and then it's closed towards the x here. X is less than 5. So it has to be everything greater than negative 2 and less than 5 at the same time. Okay, so it can't be just everything greater than negative 2 or just everything less than 5. It has to be at the same time. So we are looking here at letter A. Everything here is greater than negative 2 and less than 5. Number 4, again, an or statement. So x is less than negative 2 or x is less than 5. So let's just start talking about this. Since this is an or statement, it doesn't have to be both at the same time. It can be one or the other. If you think about all the numbers that are less than negative or less than positive 5, that would include everything that's less than negative 2. Every number less than negative 2 is also less than 5. And since this is an either or, it doesn't have to be less than negative 2. It could be just less than 5. And so that's why C is the correct answer if you take a look at it. Everything less than 5 is part of this solution. Everything less than negative 2 is already shown here. It's already part of this one. And again, since this is an or statement, either one can be true. These numbers up here, like 2 and 4, they're not less than negative 2. They are less than 5, and since it's an or statement, it doesn't have to be both, just one or the other. And so that's why this one is true. And so as we go to the next one, you can see now they've taken the same numbers, but they've put an and. So now it has to be true for both of them at the same time. So looking back at the answer we just gave, these numbers like 0 and 2 and 4, they only work because it's an or statement. They're less than 5, they're not less than negative 2. So as we come here, those can't be on this graph because this says and. So it has to be less than 5 and less than negative 2. It can't just be one or the other. And that's why this is letter B, because these numbers right here, they're obviously all less than negative 2, and they're also less than 5. It has to be true at the same time. So these numbers like 0 and 2 and 4, they're less than 5, but they're not less than negative 2. So since this is an and statement, both have to be true at the same time. So the only numbers that are true at the same time are everything less than negative 2. Fits both of them. All right, number 6. During the summer months, these two people agree on a temperature to set their air conditioner. Mr. Bowler prefers the temperature between 68 and 72. So between 68 and 72. I'm just going to draw a visual here. Mrs. Bowler likes it between 70 and 75. Write an inequality to show the temperatures when Mr. and Mrs. Bowler will both be comfortable. So we want to find temperatures that work for both of them. So 68 is good for him, not good for her. 69 is good for him, not good for her. 70 would work, right, for both of them. 70 falls inside both. So does 71. So does 72. Once we get to 73, she's comfortable, but it's too hot for him. So we are going from 70 to 72. So how do we express that as an inequality? Now you can use any variable you want. They chose to use T on the answer key for temperature, so let's go with that. When we write these, you tend to put the smaller number to the left, just like you would read it, just like you would on a number line. So we're going to put the 70 degrees here and the 72 up here. So the temperature needs to be between those. And now how do we put our inequalities? So the temperature needs to be greater than or equal to 70, can't be less. So we're always expressing it based on the variable. The temperature has to be bigger than 70 or equal to 70, or the temperature has to be less than or equal to 72. So it's always based on the variable. Open towards the T means T is bigger than 70. Closed towards the T means T is less than 72. All right, flipping the page and going to number 8. Sorry, not flipping the page. Right here at the bottom. A movie theater gives a discount price to children under 3 or senior citizens over 65. Write a compound inequality to show the ages that receive the discounted price. So they used Y for years. So the years have to be less than 3. See, it says under, not 3 and under. It says under 3. So there's no equals here. Less than 3. Or Y can be, you have to be over 65, greater than 65. That's a compound inequality. Just combining two inequalities to represent one data set. All right, that's A. And then B, they want you to graph it. So let's put 3 here. And we'll put 65 up here. And everything less than 3 looks like this. Everything greater than 65 looks like that. So if you are between 3 and 65, you are paying full price. You get the discount if you're under 3 or over 65. All right, now flipping the page. Going to number 9. So I included this question because it is important to start to see these plus or minus problems. What does that mean? How do we look at that? So that's why this one's included. So number 9, temperatures in space vary greatly. Astronauts, blah, 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 have to endure temperatures that are negative 18 degrees Celsius plus or minus 139 degrees. So what the plus or minus means, negative 18 is kind of like your middle point, kind of like your average. So they can go plus 139 from here or minus 139. So a lot of times you'll see this when you're given statistics and they're not perfect, and they'll say 40% of people like this, plus or minus 2% is the error. And so it could be 2% higher, it could be 2% lower. We know it's in that range. So this represents a range. Negative 18 is the middle, plus or minus 139. So it could be 139 above it, or it could be 139 below it. So write an inequality to represent these temperatures in space. So first of all, we have to figure out what is 139 over negative 18 plus, and what is 139 under. So we're going to do negative 18 plus 139. So that's 121 degrees Celsius. And negative 18 minus 139 is negative 157. Now notice how I ordered these, right? I put this over here, the smaller number, and I put the bigger number over here. And again, we're talking about temperature, so I'll use T. And so the temperature has to be greater than or equal to negative 157 or less than or equal to 121. So that's your inequality. And if we graph it, put negative 157 down here and positive 121 over here. 0 is somewhere over here. And we're not going under and over like we did on the last one. This is everything between. The temperature has to be between these two, and they are included. So graphing it shows it's everything in between. All right, and on our next couple problems, we're going to solve them first and get some answers. But when we go to write our final answers, we're going to kind of use these skills we've been working on with the graphs and how they relate to these inequalities to help us write our final answers. All right, so let's take a look at number 10. First thing we got to do here is just go ahead and solve these two. So we know how to do that. Minus 9 divided by 2. So x is greater than 4. And then this one, we're going to minus 8. Bring down the minus with the negative. Divide by negative 5. Don't forget when you divide by a negative, you have to flip. So x is greater than or equal to negative 1. So this is an OR. So x is greater than 4, or x is greater than or equal to negative 1. So let's put this on the graph before we try and figure out our final answer. Here's what I'm going to do. I'm going to graph them both separately first, and then we'll combine them on a graph so it makes sense. So if this was 0 and this was 4, x is greater than 4 starts here and goes up, right? If this is 0 and this is negative 1, x is greater than or equal to, so filled in, greater than or equal to negative 1. So this is from 4 up, and this is from negative 1 up. So there's going to be some overlap here, right? Because here's 4 up here. So at some point, this includes everything that this also includes. So they're overlapping. The only difference between these two graphs is this one includes the numbers between negative 1 and 4. So if negative 1 was down here, this graph includes that. Now, if it said and, we can only pick answers that fit both of these solutions at the same time. So it wouldn't include these numbers down here because it doesn't fit this one. But this is an OR. So OR means it can be in this solution or it can be in this solution. It doesn't have to be in both. So because of that, these numbers that are less than 4 are part of our final solution set because it only needs to be in one of these two. And then everything from here up is already in this one. So our final graph, let's put it all on here just so you can see it. But our final graph is going to look just like this one because we're going to show this solution. All of this solution is included. And once we draw this solution, it's already showing this one. Everything greater than 4 is already part of this. And so my final answer just looks like this. This is my final answer as a graph. Again, because it's an OR. These numbers are part of this solution, and everything greater than 4 is part of both of them. Okay, so since it can be in either this one or this one, all of these solutions are part of it. So when I write my final answer, I don't have to write it like this. I'm just going to represent everything from negative 1 up. So x is greater than or equal to negative 1 is my final answer. Okay, 11. This one's an and. It's going to be a little different when we get to our final answers. So first thing, solve them. Now, since this has decimals and this has fractions, I kind of want to put them all in the same thing. So either all fractions or all decimals. These aren't terrible decimals to turn to fractions, but this fraction is super easy to make it into a decimal. So let's just go ahead and do that. We should know that a quarter, 1/4 is 0.25. And if you forget, you can just divide 1 by 4 in your calculator. So this is 0.25. And now I have all decimals. It just makes my life easier when I have to compare these at the end. So I'm going to add 7. 0.25x less than 5 divided by 0.25. So 5 divided by 0.25 is 20. So x is less than 20. And over here, minus 3.8. and divide by 6. No flip because there's no negative. So x has to be less than 20 and x has to be greater than or equal to 0.9. It has to be both. Can't just be it's any number less than 20, and it can't just be any number greater than 0.9. It has to be both of them. So let's sketch our two little graphs first. Here's 0, here's 20. X is less than 20. That would be every number less than 20. Here's 0. Here's 1. 0.9 is going to be almost there. Filled in circle. X says greater than. And remember, 20 would be up here. And over here, 0.9 would be right here. So if this was an OR, it would be everything less than 20 and everything greater than that, and that all would be included in our final answer. But that's not what it is. It's an AND statement. So all of these numbers less than 20 that pass this 0.9 that aren't greater than 0.9, these don't count down here. These are not part of our solution because the AND tells me it's got to be part of both. And same thing here. Everything greater than 0.9 that passes the 20 and becomes greater than 20 is not part of this because it has to be true for both. It has to be this and this. So when we look at our final graph, we have to eliminate some of this stuff. So I'm going to put 0 down here. I'm just going to go ahead and put 0.9 right here and 20 up here. Since both of these have to be true, x has to be bigger than 0.9. I can't have anything down here. It's not part of the solution. And again, since it's an AND statement and both of these have to be true, I can't have anything greater than 20 because x has to be less than 20, so nothing up here. So we're just talking about what's between them. Okay, so this one does have that equal sign. So everything greater than and less than this. And so that's going to be everything between these two. So since it's an AND, both have to be true at the same time. The only numbers that make both of these true at the same time are in here. All right, so how do I write this now? This is my graph. How do I write this as my final answer? This is an interval. X is greater than or equal to 0.9, and x is less than 20. Now you can write them separate, but this is one where you can write it all at once. Greater than this, less than that. Okay, now this one, you can solve this all at once. That's kind of a slick way to do it. You can also split this into two pieces, and so I'm going to show you both ways. So let's say you wanted to split this into two pieces. Take off this part. That's your first problem you need to solve. Okay, and then the next one, take off this part. And that's what you have to solve there. Okay, so you have those two things. So let's do it this one first. So solving them separately, I'm going to add 9. So I get 5 greater than or equal to 2.5x divided by 2.5, and that's 2. No flipping. X is greater than or equal to 2. Add 9. That's 24. Divide by 2.5. 24 divided by 2.5 is 9.6. So x is here, no flip, 9.6. So those are my two answers. Let me show you how you could have done it here. It's the same thing, just combined. So we're trying to get x by itself here in the middle. So we have 3 spots we have to do things now. So every time we have one of these inequalities or an equal sign, every side of it has to be covered. Here's what I mean. So I'm, again, just focusing here on this middle piece here, trying to get x by itself. So just like I did over here, first step would be to add 9 to get that out of here. Over here, I had to show it in 2 spots. Well, now I have got 3 spots I have to show it. Plus 9, plus 9. So I have 2 dividing lines now instead of 1. And so plus 9 has to happen in all 3 of these sections. So here in this section, it goes away, leaving me 2.5x. Bring down this stuff. 15 plus 9 gets me the 24, which was right here. And this gets me the 5, which was right here. And now, again, trying to get x by itself in this middle section, I'm dividing by 2.5. These are your dividing lines, has to happen in all three spots. So divide by 2.5, and I get a 2 here. X is now by itself, and I get a 9.6 here. So you can see I get one big solution that says the same thing as this. X is greater than or equal to 2, says it right there. X is less than 9.6, says it right there. So this is a good final answer. So is this. Now this is an and statement. X is greater than or equal to 2. So if you wrote them separately like this, you would have to put an and. And X is less than 9.6. Whenever we write this as one big inequality like this on both sides of your expression, that's an and statement. So both of these have to be true. So bigger than 2, less than 9.6. So if I'm going to put that on a graph, here's 2, here's 9.6. Now I will check, this is going to be a closed circle. This is going to be an open circle. X is bigger than 2 and less than 9.6. Has to be both at the same time. The only numbers that are both at the same time are in between them. All right, last one has a little bit of work, so we're going to flip over here. Okay, there's that one. So just a little bit bigger problems. We got a variable on both sides. We're going to eliminate the smaller one first. So I'm going to take away the 20c from both sides. So I have 5 greater than or equal to, this becomes 10c minus 15. Now I've got a normal looking problem. So we're going to isolate. So 10c less than or equal to 20. Divide by 10. No negatives, no flip. Keep everything where it's at. So c is less than or equal to 2. Now this was an or. We got to keep that in mind when we get to the end. So let's solve this one now. You got c on both sides. The smaller of the two is right here. So I'm going to get rid of that one. It's negative, so I'm going to add 2c. So I still have 4. Negative 1 plus 2 is 1c. Positive 1c. And here's 9. So I'm going to minus 9. And I'm left with c greater than 5. Sorry, that's negative 5. I knew something was wrong. 4 minus 9 is not positive 5, obviously, negative 5. So there's our two answers. Now this is an or. So both of these don't have to be true at the same time. This can be true or this can be true, and we're good. So if we put these both on graphs here, here's 0, here's 2, and we'll put negative 5 down here as well. But just graphing this one, less than or equal to 2. So that's everything going this way, less than or equal to 2. This graph, again, here's 0, here's 2, and here's negative 5. This says greater than negative 5. So everything this way. So if this was an and statement, it would have to be less than and greater. So it would be everything in between. We couldn't go past it on either side. But this is an or statement. So anything on this graph is part of our solution, and anything on this graph is part of our solution. So it includes everything past the 2 in this one, and it includes everything past the negative 5 in this one. So since it's an or, everything in this solution and everything in this solution is included. Well, think about what that actually means. Here's 0, here's 2, here's negative 5. It's not perfect. So everything less than 2 is included, and everything greater than negative 5 is included. Less than negative 2, everything going that way. And everything from negative 5 up is included with no endpoint. And so that now takes up the entire graph. Come up with a number that doesn't fit in this for me. Give me a number that's not greater than negative 5 or less than 2. You can't do it. Any number you could imagine is either one of these, and that's what or means, either one. You can't come up with a number that doesn't fit one of these two solution sets. And so everything gets highlighted here. Every number is either less than 2 or greater than negative 5. And so our graph ends up just looking like one big shaded section with arrows. And this is what an all real numbers graph looks like. Again, if this was an and, it would end up with everything in between them because it would have to fit both at the same time. So these numbers down here that are way less than -5, they don't fit this solution, but they do fit this one. And all these numbers that are up above 2, they don't fit this one, but they do fit this one. Since it's an or and it only has to fit one or the other, all of these numbers are included, and that's all real numbers.